Hey everybody, this is Larry, this is me going Q3 of the weekly contest 290, count number of rectangles containing each point. So as you can see from here, actually I found this to be the hardest problem, but I'll go over why in a second, though a lot of it is just me, to be honest. But yeah, hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this problem. So the one thing that I would say about this problem is that I did look at the constraints. Oh, I have to change it back to C++. Or Python. One thing I would say is that there is this 100 constraint, which I didn't miss this during the contest, but I just did poor math, which is that I thought 100 times 10 to the 4th equals 10 to the 7, because math is hard. So friends, make sure you know how to add 4 plus 2. So because of that, I thought it would be timeout, or I couldn't figure out a way to do it in a more naive way. So once you realize that, it's actually not that bad. Basically, you do you keep an array of 100 elements, and then for each, you can, I'm hand wavy a little bit for sure. I'll go over my solution, which is in more detailed, but the way that you would do it more naively is taking advantage of this 100 by processing the rectangles and points one by one, using like an array of 100 elements, and then just keep track of, things, and just be good at keeping track of things, basically, is the idea. The way that I did it is slightly different, but has the same idea. It is using sweep line. Give me a second. I am actually taking out the drawing right now. You know me. I'm trying to be good to my fans and do some drawings. Okay. So I was gonna do a copy and paste of this actually, but I feel like that's maybe a little bit not necessary. So actually, I don't even maybe need the drawing pad, only because we'll see. But basically, you have some rectangles, or you have a lot of rectangles that are based off 0. Pretend they're all like aligned on the left side or whatever. This is just random. I don't have any points, right? But the idea here is trying to come up with an invariant such that you can process them, such that you can, such that when you process them, one of the axes don't matter. And when one of the axes don't matter, then you can maybe do some sort of binary search or something like that on the other axis, because that's basically the idea, right? Let me now use my drawing thingy because I paid good money for it. Also, I don't know, we'll see. But for example, the way that I did is just going from top to bottom, though it doesn't really matter. Like, you can also go from right to left, just going this way, right? And going this way, let's say you have a point here on top, and here is inside no rectangle, right? Let's say now the sweep line goes to this line, is the top of the rectangle. So then now we add a rectangle that goes almost like a segment, right? That goes from here to here, right? And then now let's say we have 2 points, let's say one here and one here, doesn't really matter the y-axis, but let's say we process this one, then we can do a binary search to see how many right endpoints of these rectangles are there, right? And that's basically the entire idea. And if you go here, then you see that there's none, and let's say you have, and then here you add another rectangle, here you add another rectangle, I think. I don't know how I drew it. And then let's say you're here, now you can do a binary search on the number of rectangles that to the right. Here, for example, same as well, number of rectangles to the right, to get your answer. And that's basically the whole idea of this problem. It's just this sweep line and then building out the rectangles one by one. And the reason is the kind of, it's not really an invariant, I guess it's an invariant. The invariant here is that after you process the rectangle, now you have like a boundary that creates what's considered good, right? And the weird part about this, if you're doing the problem and you came here doing the contest, Q4 has a very similar idea. So I actually took a long time on this one because, I don't know, I think I was just a little bit weird. Sometimes it happens. But yeah, so basically I do a sorted list, which means that it allows us to do it keeps the list sorted and allows us to do a binary search. And we have two types of defense. One is for rectangles, and the other is for points, right? And I also I actually don't like the maybe I'm okay, but I feel like because I did this a little bit differently than I normally do it, I think I confused myself a little bit with the way that I did the event stuff. Yeah, but that's fine. That's just a thing. But yeah, but not noticing this bit, did the math wrong is a little bit embarrassing and took me a lot longer as a result. But yeah, but one thing to also I had to keep track of the index because now our points are out of order. Same thing they have to do on Q4. But yeah, but now we go from top to bottom, or maybe right to left actually. I guess top to bottom, depending how you want to draw it. And then I sort all the events inside, processing the rectangle first. So if it's a rectangle, I add it to the sorted list. If it's a point, then we have to count how many rectangles are there. And then we do a binary search to see how many rectangles are to the left. And of course, you just do some math on how many rectangles are there currently, and that's equal to count. And I don't know why I made it two statements, but I thought maybe I had to do something funky. And that's pretty much it. A very short sweep line algorithm or line sweep algorithm. I don't know why that it is interchangeable, but it is. And as you can see, this is n log n because there's a lot of sorting, but nothing really, nested in a way. At worst, everything will be in one thing and you get sorted. So yeah, let me know what you think. Yeah, I think that's pretty much it. The other way to do it with the h is equal to 100 is that you basically do this, but with an array of 100 elements, and you just loop through it. And it's a little bit easier because I think you can process it in both directions in a more easy way, and that's why that's why you're able to do it, because you're able to process in both directions, versus maybe the way that I do it, I could probably do both as well now that I think about it. But I think that's I was just confused. I think that's maybe some days you have bad days, and today it's a little bit yikes. But yeah, that's all I have for this one. Let me know what you think. Let me know how many you counted. I'll see you later, and you could watch me solve a line in the contest next. Keep in mind that I actually, for this problem, because I got so stuck that I actually skipped to Q4 and came back. I don't know. So check that out. But yeah, check that out now. Yes, I misread that one. Okay, calm down. Solve the problem. Okay. Have a link for okay. Count sub j contains the j point. Okay. No one's gotten this yet? That's actually surprising. Maybe. So 1, 3 points. Let's see, there are a lot of points, a lot of rectangles. I think searching it should be fine, but how do we want to do this? Okay. Right now we want to something like this, maybe. This is a very hard problem, the way that I'm solving it, honestly. Okay, and then I think I did this wrong, didn't I? I think we want to look at. Oh, I see. I need like a binary index tree type thing to solve it, maybe, which is kind of tricky. Because we have to index stuff. Okay, that's awkward. Not gonna be a fast one tonight, maybe. These rectangles, we pause them. I think this has to be sorted another way. Backwards or something. This is so hard actually. Only 8 people got it. I have a wrong answer penalty. Wow, I don't know. Maybe I just don't know this one. I mean, I think I've. Oh, that is a big one actually. I missed this. Maybe. I kind of treat them independently, but okay. So that means that the y-axis there's only 100 things. That should allow us to do something. Yeah, okay. Okay, what am I doing? 10 to the 4th, 10 to the 7. What's 10 to the 7? Yeah, 100 times 10 to the 7 is still pretty big though, right? Yeah, at least, yeah, that maybe that's not good enough. I don't know how to do this one. This one's hard. So given a rectangle, can we do some sort of binary search on how many points? You can, but I don't know how to update it in good time. The 100 is way. I feel like I can take advantage of this 100. But even 100 times 5 times 4 is pretty big. How many people self queue for you? I got that one so quick, but I don't know how to do this one. That was like a 2-minute problem. Did I open them in the wrong order? Is this too hard? Nope. People already finished, but a lot of people got queued. I feel like this is some sort of sweep line, but I don't know how to do it. Well, the height could be only 100. So for each height, so let's say we sweep and we see okay, so for each point, do 100 binary search would be too slow. I feel like I need some sort of binary search, but I don't know how to set up the data structure. I mean, maybe people just do KD tree type thing as well. We could do some sort of prefix sum. That's too big, I think. For each point. How many rectangle? People are getting it though, so maybe I just don't know. Height. How do I take advantage of this height? Binary index tree and then just do suffix. Okay, I guess that's the way to do it. upside down. Let me think about how to do it. Is that true? Wait, no, that's not right. I think going backwards is needed. Okay, so let's say we go backwards, right? What happens? I have to think about how to do this backwards. Okay, so we still do this, maybe. Yeah, maybe I just have to go backwards. And now, when I get a point, happens, right? Okay, so now I can do a binary search on the number of things. Maybe that wasn't that bad actually, but I was just kind of, I had some trouble remembering this one. But from let's run it real quick. Just okay, that's good. Okay, let's see. Right. Is that okay? And then now when you go by, dot bisect right of y minus 1 maybe. That's not good, but where's the start? -1. That's definitely not good. Bisect y, okay, of y. 2, 3, 5. That sounds good. And now going from 2, you have 1, right? Oh, I did it the other way. So now given 1, we want bisect left, but we also want length of SL minus pi. 3, 0, is that right? Nope. Alright, why is that? 1 and 2. Oh, sorry, this is 2. And the y is 1. So we want 3. Yes, that's technically right. Why is that wrong? Oh, because this is 1. Because we haven't processed it yet. Going backwards, we add. Okay, I think I mixed this up, but that's fine. 03 is also a little sad. It's gonna give me weight limited soon. Okay. That's 555. Why is... Oh, whoops. 01 is clearly wrong, but let's see. 0, so then it goes 5, 3. Process the 2. Should have 1, right? So that's wrong. Oh, because I changed it back. Okay, I should process the rectangles first. Well, that's a little bit sad, but... Oh, because I changed the order and the event. Okay. Still not right. Oh, because reverse is true. Wait, what? I'm confusing the heck out of myself. Basically, we want to do the rectangles first. Oh, I saw this, but here I need a reverse is. I'm confusing myself. Okay. I feel like I got this, but I'm really bad. Okay, so sort of this. 1, 3, and 5. No, we want the... Oh. Okay. Okay, yeah, okay. I am really bad at this. Yeah. 2, 1, 1, 3, okay. Let's hope this works. Should be okay. If not, I'm just gonna be sad. Okay, cool. Yeah, thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think. Stay good, stay healthy to good mental health. I'll see you later and hope you enjoy this. Bye bye.